Enjoy? All right. So we are learning to use right-angle trig and or the sine law and cosine law to solve problems in 3 dimensions. Usually the strategy involved is going to be to find a common or shared side first. Okay, step 1, find the common or shared side. Okay, so how high is the balloon? So in the end, they're asking us, if you can see this picture, they're asking us for this side that I just drew in blue. Do you agree? In the end, that's what we want to find. And you can see that, so you have to imagine there's a triangle on the floor that I'm standing in. Okay, triangle BCD is on the floor. Okay, and then I'm the balloon string and there's a balloon above my head. Okay, we want to know how tall I am. That's basically what this problem is. Okay, so I'm standing at point C. Okay, and then there's a triangle on the floor down here. Okay, and I want to know how high it is from C to A. Okay, and then there's a balloon above my head. Okay, so if you look at the information given, you notice that the triangle that's on the floor has a lot of information given. So if I look at the triangle that's flat on the floor, I know a side, and I know 2 angles in it, so really I know all 3 angles. You guys agree? So if I look at triangle BCD, the triangle that's on the floor, I know both of these angles, this side, and I can get the angle on the top by subtraction. So I can do 180 minus, and get 74 degrees here. So now I have to know, is it smarter, is it going to help me more to find this side, CD, or CB? And who knows the answer and why? Which side will it help me more, Jacob? Yes, it's going to help me more to find this side because it's the shared side between this right angle triangle that doesn't look like one but is, that I have info on. I know there's 64 degrees, whereas this other right angle triangle on this side, I don't know anything other than the 90. Does everyone see that? So it's better for me to find CD like Jacob said, so I'm going to call that one X. Okay? And how do we find X? Well, is it a right triangle, CDB? No, it's not a right triangle. Is there a side angle pair? Yes, there's 274. So that means I can use the sine law to find X, the common side. Okay? So the common side is going to be found by doing X over the sine of 50 degrees equals sides on top 200 over the sine of 74 degrees. Multiply both sides by sine 50. $159.4, approximately 159.4 meters. So now I've got a right angle triangle that's harder to envision. Okay, so this blue one is a right angle triangle, so I always like to redraw them because it's hard for me to envision that they're right angle. So this is triangle CDA. It's got a right angle here, which you can see in the diagram, but it's hard to visualize. It's got a 64-degree angle at the bottom here, 64. And we just found out that the side C to D, so the bottom, is 159.4 meters. Okay, so C to D, we just found that out, was 159.4 meters. And we want to get A to C. I can't use X, so I'll use H for height. Okay. This is a right triangle, so I can use SOHCAHTOA and name my sides by the 64-degree angle. So this would be opposite, hypotenuse, and adjacent. And I'm going to cross off which one? Hypotenuse. I'm not trying to find it, and I'm not given it. Which means I need the formula that has opposite and adjacent in it. Tan, good. So tan of an angle is the opposite over the adjacent. Tan of 64 degrees is H, which is the opposite, over 159.4. So I'm going to multiply both sides by 159.4. And we get H is approximately 326.8. And then see if there's any rounding rule required and what the units are. Nope, it just says how high is the balloon, and it's in meters. So therefore, the balloon is 326.8 meters high. Okay, all right, let's look at the next picture and try to picture it. How tall is the tree? All right, so now I'm the tree, okay, and there's a triangle in front of me like this that's on the ground, okay? Triangle on the ground, and that triangle is ABD. Pretty good. So I'll recopy that one. So A, B, D with 400 meters here, 60 degrees, 80 degrees, which means I can get the one up at the top by subtracting 180. So it's going to be 40 degrees. And what is the side I want to find in triangle ADB that helps me eventually get to the height of the tree? Jazz. BD. Awesome. So BD is this side, and it's this common shared side in the right triangle that I'll eventually have. Okay? So I'm going to call that, I'll call it little a. It's across from angle A, but I can call it X, call it whatever you want. Is it a right triangle, DBA? No, it's not. Do I have a side angle pair? Yes, so I have 400 meters and 40 degrees. And so then I can find A using the sine law. So I've got A over the sine of 60 degrees equals 400 over the sine of 40 degrees. And then I have to multiply both sides by sine 60. So I end up getting A to be 538.9. 538.9. Okay, 538.9 meters. So now I want to draw, so I know this side here is 538.9 meters. Now I want to draw my right angle triangle, which is the triangle CDB. So I'm going to draw it looking like a right angle triangle. So here's my tree, right? And then, so there's my 90. This angle here they're showing me is, and let me label it, so this is C, D, and B. So the angle between B and the hypotenuse is shown to be 20 degrees. We just found out that D to B was 538.9. When you round to the nearest meter, it's at the very last calculation you do. Good question. And then I'll call this side X. I haven't used X yet. And now it's a right triangle, so I could use SOHCAHTOA. So I can name my sides according to the 20-degree angle, which is X would be my opposite side, hypotenuse, and adjacent. Which one would I scribble out? Hypotenuse. So I'm going to do tan again. So tan of the angle is the opposite divided by the adjacent. So tan of 20 degrees is X over 538.9. Multiply both sides by 538.9. And now as we're going around to the nearest meter. So X is approximately, so to the nearest meter would be 196, approximately 196 meters. So therefore, the tree is about 196 meters tall. Yep.
If I did using triangle instead of line, right? So
Yes. You can use the sine law on right angle triangles. If you never ever want to use SOHCAHTOA, you can use the sine law for all right angle triangles.
I've seen the sine law before. I didn't see the 90 degree angle since then. Okay.
Yes, you can use the sine law. So with the 90-degree angle, or you'll know all angles if you know 2, you know 3. Okay. Use the sine law with a 90-degree triangle if you want. All right, find X to the nearest tenth of a centimeter. So this one's kind of like supposed to be, I'm standing here, and then there's two kind of triangles going out like that. I'm the middle of them, I'm FD, okay? And they want me to find X to the nearest tenth of a centimeter. So what would the common side be that we want to find first? Think that through, so you can figure out what you think the common side would be that we want to find first, before you can get to X. Yeah. Yes. Yeah. Good. Okay, so that's really. So I'm going to redraw this triangle. So it's DFE is really a triangle that looks like this, where this is E, this is F, and this is D, and this is 90, this is 35, and this is 15 centimeters, and DF is what we want to find. So I'll call that X. Oh no, we can't call it X because X is already in the question, so we'll call it little e. Or Y, or H, whatever you want. Okay, just not X. So it's a 90-degree triangle, so I can use SOHCAHTOA. So E is my opposite side, hypotenuse, and adjacent. And I want to cross out the one I'm not trying to find and don't have, so that's going to be the hypotenuse, which means it's tan again. So tan of an angle is the opposite over the adjacent. Tan of 35 degrees is little e over 15. Multiply both sides by 15. 10.5? So 10.5 centimeters. So now I want to redraw triangle DFG. So triangle DFG looks like this. And we just found out that D to F was 10.5 centimeters. And we want to find out X. Okay, so according to my 45-degree angle, this is the opposite side, this is the hypotenuse, and this is the adjacent. So which one would we cross off this time? Adjacent side. Which means which formula would we use? Sine. Sine of our angle is opposite over hypotenuse. So our angle is 45 degrees. Our opposite is 10.5. Our hypotenuse is x. So to get x into the numerator, I have to multiply both sides by x. And then I get x, oops, I want to take that red, x times the sine of 45 degrees equals 10.5. Divide by sine 45. And I get x is approximately 14.8. And then check and see if there's any rounding requirements. Nearest tenth of centimeters, that's right. So therefore, therefore x is approximately 14.8 centimeters. You could have just put a therefore here. Okay, do you want time to try 4 all on your own? I'm going to give it to you. You want it or not? Is everyone good at 75 degrees up here at angle C? Everyone knows how to get that? Okay. And our common side is this one. X. It's not a right angle triangle, but we do have a side angle pair. So we're going to do X over the sine of 42 degrees equals 68.5 over the sine of 75 degrees. $47.5 for the common side. Okay. Is that what you got? 47.5? Okay. 47.5 meters for the common side. Then I'm going to draw a triangle ACB. A is at the top, C is at the bottom of the cliff, B is over here. We just found out that C to B was 47.5 meters. And we know this angle is 38 degrees. We want H, the height of the cliff. So, according to the 38 degrees. This would be the opposite. Hypotenuse, adjacent. Crossing off hypotenuse, which means tan. Again. So the tan of 38 degrees is h over 47.5. So h is approximately 37.1. And see if they pull this around. How high is the cliff? Nope. So therefore the cliff is 37.1 meters high. Everybody good with that one? Excellent. Great, last question. What is the distance from A to B? So this is what we want to end up finding. Any ideas? Yep.
You have to find the two sides on both of the triangle.
Yes, you have to find the hypotenuse of this right triangle and the hypotenuse of this right triangle. And then you'll have the two sides and the angle in the middle, so you can use the cosine law. Awesome. Okay, so I'm going to start off with ACP and redraw it. So ACP is a right triangle where we know this is 23 degrees and this is 18 meters. And we want to find the diagonal or the hypotenuse, which I can call little c. So I can use SOHCAHTOA because it's a right triangle if I want to. So which one would I be crossing off in this case? Opposite. Because I want to know hypotenuse and I have adjacent. So the formula that has adjacent and hypotenuse in it is cos. Cos of the angle is adjacent over hypotenuse. Cos of 23 degrees is 18 over c. So I have to get c into the numerator by multiplying both sides by c.
That's the obvious. Oh my god.
Hi, Mr. Vitti.
Did you end up getting any question structure yet?
No,
Okay.
not that I know of.
No, that's fine.
This looks weird with c and then cos, but
Does that make you want to go back to that? Getting assist, would you rather do this in person or over online? There you go. I've been looking at the screen for the last 4 days.
okay, so we end up getting c 19.6. Okay, so now we know this side, the blue side, is 19.6 meters. Okay. So now I'm going to draw the other right angle triangle, which is BDP. So it's going to look like this. Oops, no, not. Not having much luck drawing a right angle triangle. Great, Mrs. Northwood. There we go. It's better. So this is D, this is B, and this is P. And we know this angle is 18 degrees, and this side is 7 meters. And we want to know the hypotenuse again, because that's going to be the green side. And we label according to the angle we're given, not the 90 degrees. So the 7 meters is the opposite. We want to find little d, which is the hypotenuse. So we would be scribbling out adjacent. Great. Okay. So then opposite and hypotenuse is which formula? Sine. So sine of the angle is opposite over hypotenuse. So sine of 18 degrees is 7 over d. Multiply both sides by d. D sine 18 degrees equals 7. So I get D is approximately 22.7 meters. Okay, so now I know this side is 22.7 meters. So now I can draw out, if I want to, this middle triangle. So it looks like this, where we know this is 42 degrees. This is 19.6 meters. This side is 22.7 meters. And this is actually what I want to find. I don't think I've used x yet, so I'm going to call it x, the distance between A and B. ABP is this triangle. Okay? So, how do I find that? I have side angle side, so I need to use the cosine law. Good. So it's going to be x squared equals 19.6 squared plus 22.7 squared minus 2 times 19.6 times 22.7 times the cosine of 42 degrees. And I should be able to get x squared by typing in my calculator. Which gives me 238.1700085 square root 15.4 meters. So therefore, A and B are 15.4 meters apart. Whew. Okay, so do you think it's that much harder than what we were doing?
I like this one.
There, see, it's easier. There you go, there you go.
That was actually easier than the
Yeah, but we're
one that we did before.
There you go, there you go. Because he was amazing, looking for the constant. What do you want to do? I'll see another word.
Like it.
You're welcome. You're welcome.
Yes.